Okay, 2.2, solving inequalities using addition or subtraction. So we've got the addition or subtraction property of inequality, and this says that if you add or subtract the same thing from both sides of an inequality, so on this example I'm going to be adding 3 to both sides of this to get the x by itself, well then we'll end up with, it's going to produce an equivalent statement. Okay, so in other words, if this is true, then it's still going to be true when I add 3 to both sides of the inequality. And that's what I want to do, because when we're asked to solve, we really want to get the x by itself, or whatever the variable. I want to get the t by itself on this next example. Okay, so when I add 3 to both sides here, those cancel, and I get x is less than 4. Okay, so that's my solution, and then we're going to graph the solution as well. So 4 is the dividing point. And then, so I got to decide if I'm going to put an open dot or a closed dot. And this one's going to be an open dot. So some people will put it right on the number line. I like to have it float above so that it's easier to tell if it's open or closed. Okay? And then this says x is less than 4. I want all the numbers that are less than 4, and those would be to the left of 4 on the number line. So that direction. Okay? All right. So on the next problem, I'm going to want to subtract 5 from both sides. So I'm using the subtraction property of inequality here. And that's going to isolate the t. Okay, so 1 minus 5 is negative 4. So here's my solution, and now let's graph it. So I'll find the negative 4, and this time it's going to be a closed dot because it says that t is greater or equal. When it's an or equal one, then you got the closed dot. It means this is included in my solution, where the open dot is actually not included. Okay? And then I'm thinking, okay, it's numbers greater or equal to negative 4. Well, those numbers greater would be to the right on the number line. Okay? All right, next example. So I want to isolate the m. I'm going to add 3 to both sides here. So 5 is going to be less than or equal to m. Okay? And now this is a perfectly legitimate solution, and you could put a box around that and call it your answer, and that would be correct. What I like to do is put my solution so that I have the variable on the left-hand side of the inequality, because I think it makes it easier to graph. So I want it to look like these, where the x was on the left and the t was on the left. Here I want the m to be on the left. Okay, so I'm going to flip it around, and you also have to flip the symbol. If you think of the old the alligator eats the bigger number thing, the alligator's eating the m here. So when I flip this around, I still want the alligator eating the m. So I'm going to write it like that. Okay. And the reason I like to do that is because when I graph it, okay, I got a closed dot above the 5 because it is equal. And then I can just follow the directions of the arrow. So this says m is greater or equal to 5, and then that's going to be the numbers to the right. But that's also just the direction that arrow is going is the same as that one. And that'll always work out like that if you have the variable on the left. Okay? All right, so let's try this one. And you could have definitely graphed this one from this. It's just I find people make more mistakes when they do it that way, because some people will have it going to the left because of that arrow. Okay, so back to this one. I'm subtracting 2 from both sides here. So I've got 4 is less than r. I like to flip it around. So let's do that. The alligator is eating the 4 up here, so I still want the alligator eating the 4. There's my solution. Okay, this one is not underlined, so I want an open dot above the 4. And then r is less than 4, so I want numbers to the left of 4. There's where the numbers less than 4 are on that number line. Okay. Okay, on the next page, we're going to try a couple of word problems that involve inequalities. Okay, so this says you can spend no more than $210. So when we're writing an inequality here, I haven't read the whole thing yet, but just you can spend no more than $210. Just from that part of it, our total amount of money is going to be $210. You can't spend any more than that, so you have to spend something less than that, or you could spend all $210, but you can't spend more than that because we don't have more than $210. Okay. You can spend no more than $210 going to concerts and buying souvenirs this summer. NSYNC tickets cost $82. Backstreet Boys tickets cost $90. Okay, so this says write and solve an inequality that represents how much money you will have left over to spend on souvenirs if you want to go to both shows. Okay, so let's say the amount of money we have left over will be X. Okay, we've got, and then it's going to cost $82 for NSYNC and $90 for Backstreet Boys. Okay, so I've got the price of both shows there, plus the leftover money for souvenirs, and I know this has to be less than or equal to $210. Okay, so there's my, I've written the inequality, and now I'm going to solve it to see how much money we're actually going to have left over. Okay, so I'm going to combine these two numbers first, because they're like terms, right? So 80, 82, and 90, that's going to be 172. Okay, and then I want to isolate the x, so I'm going to subtract 172 from both sides. So I'm using the subtraction property of inequality there. Okay, and that leaves me with 38. So for the souvenirs, we could spend $38. We got $38 with which to buy souvenirs. So you don't have to spend all of it, but you could spend up to that much on souvenirs after you buy the concert tickets. Okay. Now this says, can you afford to go to both shows, buy a $30 NSYNC t-shirt, and buy a $16 Backstreet Boys poster? Okay, so I could write in a big inequality with all the costs, with these two costs and the cost of the two concerts. But since I already know I have $38 left for souvenirs, what I'm going to do is take the $30 for the NSYNC shirt plus the $16 for the Backstreet Boys shirt and see if that is less than or equal to 38. Okay, now just because I wrote this down doesn't mean it's true. I'm going to simplify this, and over here on the left, 30 plus 16 is 46. And then I want to see, is this a true statement? Is $46 less than or equal to 38? It's not, right? If we want to buy $46 worth of t-shirts, or no, a t-shirt and a poster of souvenirs, and we only have $38 to spend, that's not going to work. This is a false statement. So I'm going to cross that out and say that this is a false statement. And that means our answer is no. We don't have enough money for both of those items, right? You could get one of them, but not both if you only have $38 to spend on those two. Okay? That's the end of the section, and I'll see you next time.